Algebra, Unit 10, Lesson 3, Notes 3, Graphing Parabolas Practice. So this lesson has a lot of review of what we've done in the first two, but it also incorporates some word problems, some real-world problems and applications. For each of the following, write an equation of the axis of symmetry, find the coordinates of the turning point or vertex, and determine whether the turning point is a maximum or a minimum. Let's take a look at letter B. Y equals 2x squared plus 3. Remember, to find the axis of symmetry, we need A, B, and C. So we could essentially rewrite this as 2x squared plus 0x plus 3. So here's A, B, and C. Remember your formula as x equals negative b over 2a. X equals negative b is 0 over 2 times a is 2. You can't have negative 0, so it's just 0 over 4, which equals 0. So your axis of symmetry is x equals 0. To find the turning point, we plug back into the original equation. We plug that x value of 0 in. So y equals 2 times 0 squared plus 3. Well, 2 times 0 squared is just 0. Plus 3 is 3. So 0, 3 is your vertex or turning point. We need to know if it's a minimum or maximum. Remember, we look at our a value for that. Because our a value is positive, I know my parabola opens up. Therefore, this point is a minimum point. Let's take a look at D. Sometimes you might have to get y by itself first, because remember, we need it in standard form. So I'm going to subtract x squared from both sides. Y equals, I'm going to also put it in standard form. So I know the x squared term goes first, so negative x squared. I have a positive 8x and a negative 6. Remember, there's an invisible 1 here. So we have A, B, and C. Your axis of symmetry is negative b over 2a. Negative b is negative 8 over 2 times our a is negative 1. We have negative 8 over negative 2, which simplifies to positive 4. That is our axis of symmetry. We then plug into our original equation. We're going to plug in 4. So negative 4 squared plus 8 times 4 minus 6. Bring down your negative. 4 squared is 16. 8 times 4 is 32. Bring down your minus 6. Negative 16 plus 32 is positive 16. Minus 6 is 10, which means our axis of symmetry is 4, 10. Take a look at your a squared value. Your x squared coefficient, which is a, and we have a negative number, which tells me that the parabola opens down, which means our vertex is a maximum. You can go ahead and finish the rest through F. Letter G. This is something you might see on a Regents exam. Which is an equation of the accompanying graph justify your answer? Okay, so we've got 4 choices here. First of all, without doing any actual calculations, look at your parabola. Our parabola opens up. Okay, it opens up, which means I know that the y value, that the x squared coefficient is positive. Automatically, I can eliminate 3 and 4. So I'm just going to jot that down. Opens up. Therefore, it's supposed to be an E, therefore A is positive. So that's one of my justifications here. So what I want to do, I want to look at the axis of symmetry. Well, the axis of symmetry should be x equals 2. So now I only have two choices left. Let's find the axis of symmetry for these two choices. So for choice 1, A, B, and C. So x equals negative b over 2a. Negative 4 over 2 times 1. So we have positive 4 over 2, which is 2. We did get x equals 2, but let's just verify. Some of them can have, there are many equations, many parabolas that will have the same axis of symmetry. So you do want to check out that other example first, because if those are the same, then we'll move on to perhaps the vertex. So let's look at choice 2. X equals negative b over 2a. We have a, b, and c. X equals negative 4 over 2 times 1, which is negative 4 over 2, which is negative 2. So that wasn't the case for this one. This one has a negative 2, x equals negative 2 as our axis of symmetry, so I know my answer choice is 1. So right away, noticing which way the parabola opens up, I can eliminate two choices right off the bat, which will save me work, and it's a nice quick step. I still had to do work for the other two, but again, I saved myself some time. I want you to try letter H on your own. Use process of elimination like we did on letter G. The roots of a quadratic function can also be referred to as the zeros of a function. Find the axis of symmetry, find the vertex, determine if the turning point is a minimum or maximum, and list the zeros or roots of the equation. So there's a lot of stuff going on here. We have to find the axis of symmetry and the vertex, so I'm going to start with that. This is our A value, B value, and technically it's plus 0, so that's our C value. X equals negative b over 2a. X equals negative 6 over 2 times negative 1, which is negative 6 over negative 2, which is positive 3. I know I ran through that rather quickly. If you need to pause and write it down, go ahead and do so. So that's our axis of symmetry. We need to plug it into our equation to get our vertex. So y equals negative 3 squared plus 6 times 3. We don't need to add that plus 0. This is negative 9 plus 18. Y equals 9, which means our vertex is 3, 9. My A value is negative, which means I know my parabola opens down, meaning the vertex is a maximum. Okay, let me reassess here. Find the axis of symmetry. Done. The vertex. Done. Determine if it's a min or a max. Done. So the only thing left to do is to list the zeros and to graph it, of course. So what I'm going to do is I'm going to put this function into my y equals and create a table of values to help me graph it. Go to your y equals in your calculator and type in negative x squared plus 6x. Again, I want you to look for that rainbow pattern. Okay, and let's go, it looks like it happens from 0 to 6. And we have 0, 5, 8, 9, 8, 5, 0. We know that our turning point is at 3, 9. We found that out already. Also, it is visibly seen by looking at the y values. Okay, let's go ahead and graph. 0, 0. Let's pick a different color here. 1, 5. 4, 2, 8. 3, 9. 4, 8. 5, 5. And 6, 0. This isn't an interval, so this will get arrows. Okay. It's always good practice to label your graphs. Y equals negative x squared plus 6x. It's asking for the roots, which means where does it cross the y-axis? I'm sorry, the x-axis, I misspoke. So I have the x-intercepts, or crossing the x-axis at those 2 points. I'm really only concerned with the x values of those points. So the x value here is 0, and the x value here is 6. And that is noted in our table where our y value is 0. So when our y value is 0, those are referred to as zeros or roots. And again, it's specifically y. So our roots, I'm running out of room here. Our roots, or zeros, are at x equals 0 and x equals 6. You can just show that with a comma. Let me zoom out so you can see the whole problem. We found, let's just recap, there was a lot of work here. We found our axis of symmetry, used the 3 to plug it in to find our y value for our vertex. We know it's a maximum because our a is negative, so it opens downward. We created a table to plot our points and graph. Our zeros are where y equals 0, which is at the x values 0 and 6, as shown in the table and as shown on the graph. Go ahead and try letter B on your own. One thing I do want to mention, actually, sometimes you will get a parabola that will not cross the x-axis. If that ever happens, your roots are non-real roots. It's kind of like if you remember having a negative under a radical sign, there we would answer is no real number. It's similar in that aspect. When you do not cross the x-axis, there are no roots. So there are no real roots, and be sure to put that word real in there. Okay, let's jump to some word problems. I'm going to skip C because I would rather do E with you on the back, which is a little bit more involved. So I would watch me do D and E and then go back and try C on your own. So letter D. Let f be the function represented by the graph below. So the graph, this is f, function f. Let g be the function such that g of x equals negative 1/2 x squared plus 4x plus 3. So we have two functions, one that's graphed and one that we have an equation for. Determine which function has the larger maximum value. Justify your answer. So if I look at the graph, our maximum is here at 1, 6. Okay? To find the maximum for our function g, we have to go through and find the axis of symmetry and then vertex. So x equals negative b over 2a. We have a, b, and c. X equals negative 4 over 2 times negative 1/2, which is negative 4 over negative 1, which is 4. plug in 4 into the original equation here. So g of 4, so we're plugging it in, is negative 1/2 times 4 squared plus 4 times 4 plus 3. 4 squared is 16, so negative 1/2 times 16. 4 times 4 is 16 again, plus 3. Negative half of 16 is negative 8. Bring down the rest. Negative 8 and 16 make positive 8, and positive 8 plus 3 is 11, making our maximum at 4, 11. So if we're comparing the two maximums, 1, 6 and 4, 11, which function, f or g, has the larger maximum value? I would have to go with function g, as it's 4, 11. We justified our answer by showing our work. So I would say function g of x has the larger maximum. Again, our work shown is our justification. Letter E. A football player attempts to kick a football over a goalpost. The path of the football can be modeled by the function h of x equals negative 1 over 225x squared plus 2/3 x, where x is the horizontal distance from the kick, and h of x, or our y value, is the height of the football above the ground, when both are measured in feet. On the set of axes below, graph the function y equals h of x over the interval x is greater than or equal to 0, less than or equal to 150. So we have an interval and we have a function. You need to go in your calculator. You need to plug in the equation. Okay, now I'm going to show you a little trick on your calculator. First, let's get our table set up here. You have to go from 0 to 150. It is completely unrealistic to think that you have to plot 150 points. So we're going to skip around here, okay? It's the only thing that would make any sense. So let's take a look. In your y equals, make sure you clear out what you have in there. Negative 1 over 225 x squared plus 2/3 x. And go to your table. If you look at your table, you have a lot of decimals. Well, I wouldn't plot the decimals. Let's plot our integers. So at 0, I have 0. And we can't go before 0 because our interval starts at 0. Scroll down until you see your next whole number, or integer, I should say, and your y values. My next one is at 15, 9. Keep going. The next one is at 30, 16. 45, 21. 60, 24. 75, 25. 90, 24. 105, 21. 120, 16. We want to go until we reach 150 here. 135, 9. And then 150, 0. And if you notice, it has that little rainbow effect in the y's. Okay. While I graph this, I'm going to cover my table up so I can maximize it on your screen, but make sure you have this table jotted down on your paper as well. When we're graphing, we need some labels here. It tells us that h of x is the height of the football above the ground. And our horizontal axis, our x-axis, is the horizontal distance from the kick. So let's go ahead and label those. Okay. Well, the x values we have go from 0 to 150. And our y values, if you look at your table, oops, go from 0 to 25. Well, what I would do here, you want to maximize your graph. You want to use as much of the space as possible. So don't count by fives. You'll end up down here in this small portion. You want to expand it as best as possible. I can't count by ones. There wouldn't be enough spaces, but I can count by twos. So go ahead and count by twos. Now, you can write every number in, 2, 4, 6, 8, 10, etc. Or you can be selective on what you write in. For example, I might just write in every 10. So 2, 4, 6, 8, here is 10. 12, 14, 16, 18, here is 20. 22, 24, 26, 28, and here is 30. A little higher than we need, but that's okay. This is very useful when you have bigger handwriting or there's a lot of numbers you don't want to crunch in there, okay? On the x-axis, again, we're going from 0 to 150. This one, if we count it out, it looks like we can count by fives, and that would actually be perfect. However, I'm not going to, zero's in the corner, I'm not going to put in every number, so I'm going to count by tens. So 5, this would be 10, skip 1, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, and 150. Okay, go ahead and plot your points. We have 0, 0. We have 15, 9, 30, 16, 30, this would be 10, 12, 14, 16, 45, 21, 60, 24, this is 20, 22, 24, 75, 25, and then we're back to decreasing, 90, 24, 105 is at 21, 120 is at 16, 135 is at 9, and 150 is at 0. This is an interval from 0 to 150, so there are no arrows. Well, let me do a thinner line here so you can see it a little better, and I'll change the color up. Mine's a little off there. Okay. Hopefully your curve is a little bit better than mine here. Okay, so we have graphed it. Now let's answer some questions. Remember, we're talking about a football. So if you can imagine, this is the path of the football. Okay, the height of the football above ground, it's on the ground, gets kicked up, reaches a maximum, and falls to the ground. okay? The horizontal distance from the kick, so imagine the kicker over here in the football, and imagine this being your field. So when they kick it, it ends up on the other side of the field, okay? Determine the vertex of y equals h of x. Interpret the meaning of this vertex in the context of the problem. So our vertex is our turning point. Our turning point happens here. Remember, it's also shown in our table here. So our vertex is 75, 25. And let's talk about what this means. Remember, 75, the x value is the horizontal distance from the kick, and 25 is the height the football is above ground. And this is the maximum. So what we can say is the highest the football reaches is 25 feet in the air, and that's at a horizontal distance from the kick of 75 feet. So go ahead and jot that down. Pause if you need to. The goal post is 10 feet high and 45 yards away from the kick. Will the ball be high enough to pass over the goal post? Justify your answer. Now, hopefully you recognize this right away, but it says 45 yards and 10 feet. If you go back to the original problem up top, it says that both the x and y axis are measured in feet. So I need that 45 yards to become feet. Remember that yards, to convert it to feet, we just multiply by 3 because there are 3 feet in a yard. And that equals 135 feet. Okay. So what that means, 10 feet high and 45 yards away, so we're looking at the point 135, 10. So let's plot that on our graph, 135, 10. 135, 10 is right here in this area. Let's make that a little bigger. Okay, that's 135. Oh, nope. Plotted that wrong. It's actually right. I gotta make this bigger. Here. That's the goalpost. Did our football make it? It's a little tough to see, but the line shows our football. And our line is below that goalpost mark, which means our football just misses the goalpost. Okay? So let's jot that down. We're going to say no, and let's justify our answer, because at 135 feet, if you look at your graph, 135 feet, the ball will be at a height of 9, and that can be found in your table as well. And this is just shy of the 10-foot high goalpost. Okay. Make sure you finish up the rest in this set of notes.